Hello everyone, welcome back to our course on computer vision. I'm Kaustav Tripathi, your instructor, and today we are going to talk about thresholding. So thresholding is a very, you could say, important concept in image preprocessing, and because with the help of this concept, you can find the hidden features inside of an images. You can basically what thresholding does is it separates the background with the foreground. With you wanna if you wanna extract something, some object from the image, you wanna remove the background and you wanna extract that object. So this kind of all these things are done with the help of thresholding. So, like if something is hidden with in image because of its colors and all, and you couldn't able to emphasize on, you couldn't able to see it, but with the help of thresholding, you can differentiate that object with the whatever the color that is hiding it or the background that is hiding it. So basically, we call thresholding is to separate background from the objects that we wanna work with. So now there are lots of methods in the thresholding. Okay, let's get on to a spider ID and see what those methods are. Okay, so here we are. Now this is a normal general program importing Lena image and just showing the image whatever that image is, and using wait key and destroy all windows. You see this is a Lena image. Okay, so now there are lots of methods in thresholding. Basically, like um, sorry, um, thresh binary. Then there is thresh binary inverse. Then there is a trunk. Then 2 0 and 2 0 inverse. Now these are some general or you can say simple thresholding methods. I would say there are lots of better adaptive thresholding methods that I will explain later on in the course. But in this video, we'll talk about these general thresholding methods and we will understand what really thresholding is. So let's remove these and let's apply them over here in our program. So as you can see, I've imported this image in the program. Now I'm gonna but one thing we need to understand is thresholding applies. If you wanna really work with the thresholding, you need to work in the black and white image, or you can call it a single scaling image, because a single channel image. Sorry, because in the color image, I will show you the problem that you're gonna face with a color image and the when you work with a black and white image. There is a kind of a difference, and you would feel comfortable with working with the black and white images in comparison to the colored images. So I will show you in the both ways. You'll see it, check, find out what are the problems that we will face, and do whatever the better option you like. I would prefer black and white. If you prefer colored image, working on color images, you can. It's your choice. Okay, so and let's create a make a black and white of it. So I will do image one is equal to cv2 dot cvd color, and here we're gonna give it two variables arguments. Sorry, image one, the source image, and the method, the code that we are going to apply, that is cv2 dot color bgr to gray. Okay, right now our image is in bgr color and we want to convert it into a grayscale, so bgr to gray. So if I run it right now, I'll see our image becomes a grayscale image. It is black and white. Okay, single channel image. Now what I'm gonna do is, now we're gonna use our thresholding methods. So let's image2 is equals to, now to use the thresholding method we use this cv2.threshold, and threshold requires these arguments. First is a source image, and I'm gonna give image 1. Then it says thresh, means threshold value. So basically what threshold value thresholding is like, there is some kind of a value at which before which something else is gonna happen, and after that threshold value something else is gonna happen. So that is like a threshold point. point that divides the two pixels, or that divides your pixels between each other. So same thing is, I'm gonna give some pixel, as you know our pixel lies between 0 to 255. So I'm gonna give it something like in between like 140, let's say. Okay, then I'm gonna give it a maximum value. It's asking for the what is the maximum value. So I will give it 255. Then the type. Which type of thresholding I want to apply? I've showed you there are lots of types. I've shown you like 5 types of thresholding. So here we're gonna use one of them, CV2 dot thresh binary. You see here these are all the lots of types of binary thresholdings. So we're gonna use thresh binary, and this is it. Now what we're gonna do? We're gonna show the image. CV2 dot show, and as this is binary image, I'm gonna write binary over here, image 2. Sorry, 2. Okay, so it looks all good. So let's run this. Okay, there's some kind of an error over here. Wait a minute. Okay. And you know, program just got interrupted in between, so my waitkit destroy all windows is not working. That's why I'll now again have to restart my kernel. Okay, so basically we were missing one thing around over here. Now this this threshold method takes or gives out 2 outputs. So it doesn't just gives one output; it gives 2 outputs. So one output is the the image that we are just gonna form later on, and the second output is the threshold value that we are using. So this threshold method gives 2 outputs: red, image 2. In red gets the whatever the threshold value we are using, and the image 2 gets whatever the image later on is being formed. So now if I run it, it has to work perfectly fine this time. And as you can see here, yeah, both the images are here. Oh god. Yeah. So you see here what I did over here in the program. If you see, I said 140 is my threshold after 255. So basically you see what it did is, whatever the value is below 140, it make it all 0, and whatever the value is above 140, it made it 255, the final largest value that we have given, max value. So if you see, whatever the dark portion over here is in this image is all converted to black, 0 pixel, and whatever the light portion in this image is like this section, this section, this section, it all converted into white. So it helps us in finding out the darker regions or the lighter regions inside of the image directly by using this. And also, if I just right now if I change the value to like, let's say 100, and change this also, let's say I want to put it to 5. Okay, my max value is right now 225. No big deal. Now if you see this image, okay, now it break down the image at 100 pixel. What do you say? Yes, at 100 pixel. Whatever the value is below 100, it will make it all to 0, and whatever the value is above 100, it will make it all to 255. This white, all of this section becomes 255. So this is binary. Now if we try some other, one thing more basically. This is not a white. Basically, it does not convert it into 255. It actually converted into 225 pixels. This is not perfect white. Okay, that's why it is converted into 225. And you can see here in the image 2 also. If we check this RFC, you can see here it has converted all of them that is above our threshold 100. It all converted to 225, and whatever is below threshold, if we get somewhere to see, whatever is below 100, it all becomes 0. You see, there's the sections. So uh, with this you can see, understand clearly what is happening over here. Okay, whatever is below 100 becomes 0, and whatever is above 100 becomes 225. Now this was one way of thresholding, of finding differentiating between them. Now there's another method. Let me just copy it. Control C and Control V. Okay, now another method is binary inverse. Okay, now we're gonna use the same values, or we'll just put it to the no, let's see, put the same values, and I'll make it image 3, and I'm gonna create one more cp2 dot show. This will be binary inverse and image 3. Okay, so all of it done. Now if I run this much, now the exact opposite of it has happened. Now with what you would have understood, we are using binary inverse, so that means opposite is going to happen. Now you see, whatever the portion in this binary image is white, it all becomes black, and whatever the portion is black is all become white over here. Now you see this strip around here is black in this binary one, and in the inverse binary this strip becomes white. Same things for the this section. All of this, that's why it is binary inverse. Like suppose I want to grab the face, you see this all black faces become black, and this the face is white, and eyes are just differentiated in the black because they are darker, the hairs are darker, that's why they are black. Same thing, just opposite, like we are fetching the background or something. So this is binary inverse one way. Okay, so and you can see here the value of the red that I told you, it accepts the value of the threshold. Whatever the threshold you are providing, it saves that value inside of a red variable. That's why it requires two variables, and that's why we face the error that time. So now we will try another methods. Now this time I'm gonna just wait a minute. I'm gonna write down all the methods. Okay, and then we're gonna see them together. Okay, so another method is, let's make it image 4, this image 5, and this image 6. Then there is thresh trunk method. Then there is thresh to 0, and then there is thresh to 0 inverse. Okay, so these are all the methods. This I'm gonna write as cp2.show. This one is trunk and image 4. And this time to 0. Image 5. cp2.show, and this time to 0 inverse. And image 6. Okay, so we've done it. We have done it on same. Okay, let's the picture was not that clear and understand. I'm gonna change it back to 140. Okay, it will help us work better with images. Now if I run this whole set of code, oh, we got a lot of pictures over here. Now first I'm gonna find the original one. Wait, this is not the original. This is the original. We have already discussed binary and binary inverse. I'm gonna remove the binary from here and binary inverse from here. Now we've got this original, and there this is the trunk. Now you see they look almost similar, but with the trunk there is one concept in trunk, like whatever the value is. So wait a minute, let me put them down, minimizing them. Okay, so whatever the threshold we are providing, like right now we are providing a threshold of 140. So what it does, whatever the pixels values that are below 140, they will remain whatever they are, they will not change. But whatever the values above 140, they will convert to 140. Like it's if some place the value is like let's say if you see this in the original image, you see this is a lot wider section. It must have a value around 200 something. But if you see in this image, it converted to a gray, that 140 pixel. So all of this section, whatever that is above 140 becomes 140, and whatever is below 140 that remains constant. So everything that is here white earth, that all becomes 140. So if I just change the value over here, okay, I will show that thing later on. Just just understand this concept. Whatever the value is above 140 will remain 140. Will convert to 140, and whatever value is below 140, that will remain whatever they are. So this is the trunk concept. Now I'm gonna remove this trunk image and I'm gonna show another one, that is 20. Now what this 20 in this concept? Oh, okay. Oh, I just pressed the wrong button. Here. So this is our original image and this is our 20 image. Now 20 is almost similar to trunk. Now a little bit different, not similar I would call it. But what happens in this? Whatever the value or whatever the threshold value we have given, below it, it converts it into a 0, and whatever is above it, oh, again I press some key. Let me run it again. Shape. Yep. Now this is our original image, and this is our 20 image. So in 20, what happens is, whatever the value is, whatever the threshold we have provided, below that threshold, everything becomes 0, and above the threshold, it doesn't change. So like I have provided a threshold of 140. So whatever is below 140, like these darker sections over here, these hairs, and this background over here, this strip, all this becomes 0. And whatever is above 140, that all remains same the way they are. So this is all same, but if you see, there is a shadow on the nose, the eyes section that is darker, and that's why it all became dark, and you couldn't understand the image properly. But basically, whatever the pixels is above 140, they are all same. Now if you see here in this section, there is a little bit of a shadow coming, that's why it is darker, and that's why it's showing a little bit of a blackish sprinkles around there. So this is 20, and when we talk about 20 inverse, here it is. Yes, this is our 20 inverse over here. Now by the word you would have understood, 20 inverse will be just opposite of 20. So it says whatever the value is below, whatever the value is above threshold will become 0, and whatever the value is below threshold will remain same the way they are. So same thing applied over here. Whatever the value is above threshold becomes 0. Like you see this white section, this white strips over here, they all become 0, converted to 0. This glowing face, just you could say just opposite of this image is the 20 inverse. So this is all the thresholding when we are talking about a black and white image. But I told you I will show you also with a colored image. So if I remove all of these and I just put a comment section over here. So basically what happening is, now I'm using the original image, and now if I do it, you see they're all like colorful images. And as earlier trunk was looking almost similar to original, same here, trunk is looking almost similar to original. So in this also same thing is happening, and though this threshold 140 is working on the all of the pixels, okay, on all of the 3 scales. Now if there is a now these colored images are the combination of BGR. Now suppose, now you've seen these images, okay, I'm just removing it right now. Now suppose at some pixel I have a like a BGR combination of like 100 comma 200 comma 150, and I am using a threshold binary. So what it is gonna do with that pixel is, it's gonna convert the threshold binary into, okay, wait a minute, it's gonna convert this threshold binary into like a I'm using 100, it will become 0, comma, now 200 is above 140, so it will become 225, at 225 is the highest one, and third one is also above 140, so it will become 225. So this color combination, it will convert it into this color combination, which is like not useful much to us, because it all changes the color, whatever the color we are doing, it is just changing the color of that image. So that's why we don't use it in the colorful images. Now let me remove it and show you. Now see, this is our image. This is our image, and you match it with a 20 inverse. No, what you are getting from this? You are hardly getting anything, because all of the colors are getting changed. Like this strip somewhere getting blue, here's getting this color, and body is also getting bluish and blackish. There's no, means like you can't find or characterize or get features out of this image. Same way if you talk about this with a binary. Now this is what I was talking about, the binary image. Now this is what is happening. It becomes a red color, because yeah, all of these lighter sections, these are, all this orangish or yellowish lighter section are because of the red color, and as you see, these are all high in the pixels. That's why it is all converting into a red, because red is become max to 55 to 25, I would say, and that's why it is becoming, this image is becoming like this, looking like this. Now this section has a highest blue color rate, so it is giving a high blue, because blue, this time blue is max. So we basically don't get much of the features from the color images. Now in some cases, like hardly in few cases, we also apply this feature, colored feature also. We use this method also to get characteristics in some images. But basically we use it with the black and white images, because there is only one scale, light or dark. So that helps us differentiate images between two features. Now here we have got a lots of, like there are lots of colors to differentiate with. That becomes harder. But when we talk about light to dark, there is only one color stream. Either it is a light or it is a dark one. There is nothing in between. So that becomes easy to differentiate with and to work with. That's why I would prefer using colored images. But it's your choice. If you can, if you find yourself comfortable using with colored images, it's your choice. You can work with them. Okay, so this is all about thresholding of images, and this is a general thresholding basically. And the next video I'm gonna tell you about adaptive thresholding, in which all the thresholding, all the, this, like right now we have given it a limit of 140, but in adaptive thresholding, that limit will change according to pixels. So I will show you in this next video. Keep watching our channel. If you haven't subscribed the channel, just subscribe the channel to get the updates on the latest video. Thank you.